Hello everyone and welcome to today's webinar session hosted by Magna Infotech Care Services. Magna Infotech Care Services is a learning platform aimed at bridging the gap between one expertise and growing industry expectations. The prime objective is to provide IT skills training to individuals, aligning them to the skill set that are most sought by organizations today, while also preparing them for future industry trends. This webinar provides a brief overview of DevOps and tools one must know and would be useful to a wide range of professionals. Leading organizations across the world have adopted DevOps methodologies to overhaul their performance, security and team dynamics, with more and more companies jumping onto the DevOps bandwagon. It has emerged as a highly sought after the skill to master. I take the pleasure of introducing the speaker for today's session, Mr. Naresh. He has extensive knowledge of numerous software applications and operating systems used by business, including middleware, database systems, and cloud-based systems. Skills include DevOps, Docker, Jenkins, Kubernetes, and Sibyl. Over to you, Naresh. Thank you.
Thank you, Aishwarya. Hello everybody, this is Naresh here. So I'll be taking the demo today. So, right. Thank you for the introduction also, Aishwarya. So as Aishwarya said that, right. So I have an extensive experience in the IT industry, where I worked on various DevOps technologies, and I'm working as a DevOps solution architect right now. So we daily work on our various tools that are involved part of your DevOps. So let's get started, team. Here we are here to understand what is DevOps, right? And then hope we might have various people in this session. Maybe somebody knows DevOps already, some may not know DevOps at all. So we would like to start from the basic. Okay, we don't directly jump onto the where we can try to jump onto the DevOps, and we don't speak about the DevOps. That is what we don't do. We always start from a basic, or let's just have a quick agenda what we're going to do completely today first of all, and then later I'll jump onto the things which we're going to discuss on. Okay. So as I said, this is a complete agenda, team. So we're going to discuss about DevOps and its applications before DevOps, what is there, and we're going to discuss about it, and we're going to discuss about the tools that we're going to use it, or continuous integration and all. Okay. So the continuous integration, continuous CD pipeline, there is a demo we can show you how exactly the CI/CD pipeline works. The quick demo, we can just take that application code and we deploy into an environment. So the complete flow from development to the operation side to the maintenance. So that's we can show up, and then after that one we can discuss about few things about how DevOps is working on in the market right now, like who should also be learning DevOps, and how you can learn the DevOps, and all those things we're going to quickly discuss. This is the quick agenda, team, for the next 1 hour which we're going to discuss. So with that said that, right, so let's jump onto the DevOps discussions. So as I said, team, we're not going to start with the DevOps directly. So I would like to start with the basic thing, right? So what I mean to say is just, we are in an industry called as software industry. So we try basic things. Let me get this one. So DevOps and its applications. So this is not the one. So before this one, team, I would like to start with another one, which is the definition of your software in the software engineering, right? So as I said, we are in a software industry where we are trying to produce softwares or create some softwares and deliver it to the end users in order to make our life easier. So what is the software engineering says for us is something, the application of a systematic, disciplined, quantifiable approach towards your development, operation, and maintenance of a software. So this is a very basic definition of a software engineering, because we are all software engineers. We just should know this basic step first of all. So this is what it is, right? So we are discussing about softwares. Every day we're discussing about a software only. So how to deliver the software to the end user, right? How better we can deliver every time, how fast we can deliver the new features or new application features, new softwares to the end user. That is what all we are talking about every day. So there itself we come to the process of various process, how to deliver this into the end user, right? So that is what it is. In order to deliver this one, team, we generally have a process called as SDLC. So we usually follow, or everybody usually follows something called as software development lifecycle process, right? In order to produce a software, create a software, we follow something called as software development lifecycle process. So in which it will tell that how to plan, analyze the code, analyze the requirements, and then finally design the requirement, then implement it, then test it, and then finally you send it to the end user and you start maintaining the software. This is what your software development lifecycle says to you. You have to get the requirement, plan it, design it, implement it, test your application, ensure that it is working as expected, and then finally, once we deliver to the end user, we start maintaining the application or a software, we call it. That is what we actually do it in day-to-day, right? Every day we are trying to achieve this process. Now, if you discuss about this, right? So, what are the various processes that we were following before DevOps, right? Before we talk about the DevOps, we need to understand a little bit about what exactly was there before DevOps, right? So that is what we just going to discuss about things. So the first process, right? I know that we went back ahead a little bit back, so we can think about how we used to develop this software at the initial stages of when we started with IT industry or something. So the initial stage was something we used to follow something called as waterfall model. In this waterfall model, yes, we get the requirement from the client, and then we follow some set of rules or step-by-step process here, and at the end we deliver to the client or an end user basically. But what is the disadvantage here? Since it is a step-by-step approach, it will take a longer time to deliver the software into the end user, right? And by the time we deliver the software to the end user, the requirement also gets changed. That is the problem with this model, right? So in order to overcome this or something, now that's what it is, right? So this is a waterfall model team. That's what we're saying it, very simple. Okay, this is a very basic software model we used it. This is on the development side, right? Means that whenever I talk about a software engineering, it's not just about the development, but it is also about your operating your software as well as maintaining their software, where exactly you're going to do it. So on the application development side, yes, we follow this process, but how exactly we deliver this application into the market, or how exactly we host this application so that it will be available for the end users, right? So there comes the concept of here, hosting these applications or softwares into the servers. Just to make you clear that in general, we usually host web applications or enterprise applications, we call it. They usually hosted on a server like a web server or an application servers, right? So we host them on the server, so that becomes a service. Now the end user can send a request into the server and they start accessing the applications over the internet or over the network, we can call it. So how to deploy this application into a server, where exactly we used to deploy these applications in the industry. So on the development side, for coding part, yes, we followed the waterfall model. By following this model, basically we developed a software. But once after we developed the software, where exactly we deployed it, right? If you come to that situation, right, this is the era, right? So we used waterfall model, and then when we are developing this application in waterfall stage, we used to have an architecture called as monolithic architecture. In a simple words, if I say that monolithic architecture, it is right, where you bundle all the components of your application in a single package or a single process, basically we can call it. A number of application features or components that are required to run your application, everything is packaged as a single bundle or a single executable file, and at the end of the day, it used to run as a single process. What I mean by here from single process here, if there is a single problem with a single issue also, then we have to completely take down the application, and then we have to redeploy the whole process, right? Redeploy the whole process that is running it. So in a way that, for a single small issue also, we are depending on the server where, it is like you have to redeploy everything. So that is the problem with this. Monolithic architecture is hard to maintain. That is what we just discussing about. Okay, so that is about it. Now, okay, that is an architecture side, that's fine. But as I said, like when it comes to the operation side, or where do we host this application softwares, or the software that you developed, we require a server basically. So the server could be your application server or a web server, kind of a server we need it. But in order to run those servers, we need machines basically, or kind of a physical box, physical infrastructure, where you can put your software and you can start making as a service. So that reason team, we used to use something called as physical servers in that era. Physical servers have their own advantages, but usually the physical servers are nothing but the huge capacity servers, where we are failing to utilize the resources of your physical servers effectively, and hence it is It is like costing more to the organizations, and it is hard for us to maintain a lot of hardware. That's the process it goes, right? So that physical server have their own advantages, but at the same time it is a lot of cost, or a lot of maintenance cost comes with the picture. It is not so easy, not reliable on the resources side, like we are wasting a lot of resources. So that is why it is still good, but we are not going to use that one. People doesn't wanted to waste a lot of things there, so that is why we switch to the next area. Now that is about servers we use to host the application. Now usually we keep the servers in a place called as data center, which means that every organization will have a place where they keep all of their servers and everything. That place we used to call it as data center, right? Now this comes to the first era of your application industry, right, or software industry. This is not the first evolution of your IT. When we started with IT, this is what we used to do it, right? Now after this one, right, we switched over because we found various problems here. So we just wanted to improve ourselves, and we just want to make application delivery faster into the end user. So we switched our process a little bit, and then we jumped onto a process called as Agile, right? So the Agile was a process brought in, or over the time, or over the night, it made a revolutionary change in application development process, which means that when we started with Agile in the application, software industry, everybody, like, rather than developing your application in a step-by-step process, or where you get the requirement and you develop it sequentially, we get the same requirements in bits and pieces, or you divide your application code, or requirement into your sub modules, and then you work on each module parallelly, right? So the parallel development goes with the Agile process. So that is what Agile brought in, a revolutionary in the IT industry, that everybody started developing the application very faster, right? So the application development is very faster when it comes to the waterfall model, and then we started delivering the application to the end user so quickly, so that the end user was enjoying the features of your application, whatever it is you deliver to the end user. Now how Agile was helping it basically, right? I mean, if you guys might already know this process team, but I'll just quickly take you through that 2 minutes. Okay, so usually in an Agile team or Agile process where you have a product owner, he usually talks to the end user or a client, and he gets the requirement, and he keeps on writing some setting called as user stories, right? He keeps on writing some user stories and keep it, and there is a team called as Agile team, or Scrum team we call it, where we have skilled people, those who can work on this requirement, right? And then they can start taking, based on the priority which is given by your product owner, they start taking the requirement and they start developing it. Now, in order to maintain this team, or there is a coach or a mentor for this team, always we call it as a Scrum Master. So he will help these guys mentoring, or he will help whatever the requirement they have it. This guy will actually help it, right? So this is what they used to do it, and then we used to have this plan for whatever the requirement that you take in, we're gonna have it finish in a specific period of time. That is usually called as sprint iteration, right? A sprint iteration usually ends within 1 month, means that we are just taking a bits and pieces, right? So we usually get a specific time period in which you need to finish your task which is assigned to you, right? That is usually called as sprint iteration. This is sprint iteration usually takes 1 week or 1 month. Usually we go for 2 week sprint. That is the standard that everybody follow usually, but it can last up to 1 month. Right. So within 2 weeks, whatever the requirement or whatever the user stories that are assigned to you, you have to finish the task and you need to deliver it back. But if you have any issues in writing the code or finishing your task which is assigned to you, now there is a call called as a sprint call, daily stand-up call we call it. The Scrum Master will hold this call, and he keeps on checking the status of where you are working. If there is any dependencies that you need to finish your work, means that if you have any impediments that you need to, before you finish your task, is there any impediments for your task? So if there is something, then he will try to help you, resolving those issues and all that stuff. That is usually we call it as a daily stand-up call. That is, we do it every day, and then everybody would answer like 3 simple questions, like what did I do yesterday, and then what I'm going to do today, and then what is there any issues in finishing this work for me, right? This is what it is. So this is the standard set of questions every day we have a meeting, and then everybody listen there. Everybody have to give their updates there. That is what it is. Now, once you finish with the end of the sprinting, by the end of the sprint, you normally finish with your work, right? Once you finish with your work, you have to do a demo, which is called a sprint review, we call it. A sprint review is nothing but where your client or your product owner comes, and whatever the work you did it, you have to demo to them. If they accept the user story, then you are done with the requirement for that sprint. Right? In this process, right, once this is done, whatever it is, demonstration is done, then you get feedbacks and everything. So your work is done. After this one, we're going to do some other meeting also called as sprint retrospective, right? A sprint retrospective is nothing but what went well in the last sprint. We can discuss about those things. What can be improved also in the sprint, like about the last sprint, what was the way which is good we went, how we did it, and is there any something wrong we did it, then how can we improvise, and then what are the action items so that we can keep on improve ourselves, right? This is the whole process of your agile, which is followed in every organization nowadays. This is what it is, right? Now this cycle is completely, like it's a never-ending cycle, team. So they keep on following that. You keep on getting the new requirement. You keep on working on the same set of requirements again and again. So at the end of the day, the way you are developing the software has become faster because we are developing in bits and pieces, or we've taken the requirement as a very less requirement. We are delivering immediately to the client. So this way we improvised a lot in delivering the application software into the end user. So people have started enjoying their features accordingly, right? That is what happened. Now, that is again the development process, but what about the application architecture side? So where we tightly coupled, so we had a lot of issues. So we changed from monolithic architecture to NTR architecture. NTR architecture is something we divided the components rather than packaging them in a single bundle. We actually divide the components, right? Like you have a front end now, middle tier, or a back end. So like a database is deployed separately, and the application code is deployed separately. The front end UI part is deployed separately. So we divided the components so that it became N tier, so that it became easy to maintain your application infrastructure. That is what it became. So NTR architecture will help you, the segregate the components into different servers, where you easily identify the issues with any of the component, and then you can just work with that component easily, right? It usually, reduces your MTTR, nothing but mean time to recover your application service if there is an issue with it. That is what it is going to do it. That is what is called as NTR architecture. We used to have it, right? And after this one, team, in order to host this application, we need a server, as I said, right? A server can be, now we switched from physical servers to the virtual servers, right? So what exactly is the advantage with the virtual servers now, right? It is like, we switched, or we divided the same physical servers into n number of virtual machines, right? So every virtual machine acts as an individual server for you now, and then every application, or you can, on a single physical machine, you can use n number of virtual machines with n number of different applications can be deployed. Now another advantage here, every application or every server has allocated some set of resources. The resource utilization also became very easy, or very effective in the virtualization area, right? So this is what is happened now. That is comes to the virtualization part. Now once the virtualization is, this is what it is. We have a data center. To host these virtual machines also we use data centers, but in some cases where you don't have a space in your data center, now if you still want the servers immediately to host your application, then we borrow some servers from the XYZ company. That is nothing but we can call it as a hosted data center. Hosted data center is something, team, rather than you getting the servers, rather than you procuring the servers and putting in your data center, we go to an XYZ company and then we start borrowing the servers or rent some servers, and we deploy our application in their rented servers. So that infrastructure is maintained by XYZ company. So that becomes the hosted data center for us. That is what we actually did it. Now this is what it is, right? This is what the second stage of your evolution, we called it about it. This is what it is, team. So I know we're discussing a bit back here. So does anybody have any questions so far here? Whatever we discussed. If you have any questions, team, you can put it in the chat window. I can look at them and I can answer. I'll pause here for a minute before we move on. So if you have any questions, please do put them, and then we can start. I'm sorry, is everybody okay with it so far, or any questions you have? Okay. No questions? Thank you so much. Okay, so great. If you could speak, thank you so much for letting me know. Okay, go slow. Okay, great. Okay, thank you so much for letting me know, team. This is what I was expecting. So thank you. Hosted is cloud storage. It can be called as a cloud, but not really the cloud. Cloud is nothing but a pay-as-you-go service, but hosted is something you go and rent something for some time, right? That is a different case. Okay, thank you so much for letting me know, team. I hope, this is okay now, I believe, right? As somebody's requesting me to go slow a little bit, then I'll definitely go for it. Okay. Whatever we discussed so far, I think this is about waterfall model and agile model, how to host this application, various ways of service. That is what it is, right? So thank you so much. Now let's speak about this, right? What is the next stage here, team? That is nothing but, we call it as DevOps, right? That is nothing but we are moving into a stage called as DevOps. We are after Agile, everybody now talks in the market about the DevOps. So that is what is the next stage anyway. So, but before we talk about your Agile, right? Before we talk about your DevOps, what are the challenges that we had with your Agile so that, you will be able to understand why we are moving to DevOps, right? So if you think about the challenges, team, for your Agile process, right? So I would call the first challenge was nothing but your infrastructure readiness, right? Why I'm calling that infrastructure readiness is a big issue with your Agile process was, so as I said, like Agile process was brought in your development side where your application development was rapidly changing or, rapidly developing your application code, right? But how about, because, you need to host these new features into an infrastructure or a server basically, is your servers are capable to hold these new features immediately, because every day or every sprint you are delivering a new feature, right? Are you preparing your infrastructure also to hold these new features on the server, right? That is what it is. So are we doing that? That is not is happening, team, here. That is the reason, infrastructure readiness is the biggest question, right? Whenever we want to go and host a new application or a new features into the infrastructure, is there any change in the architecture side? If there is a change in the Java versions, so are we working with the infrastructure folks or those who deploy these applications into the servers? Are we working with them or not, right? So that is where we are lagging something here. The infrastructure is not getting ready. Though your application is ready, sometimes we are not able to deliver it to the end users immediately because the infrastructure is not getting ready, right? That is one of the challenges we had it with Agile. That is what we need to resolve it, right? That is one of the thing, okay? And apart from that, scalability is also a big question. I think I'm speaking loud, team. I'm not sure if somebody have any issues here with my voice. I'm speaking loud enough. Is it something you need to increase your volumes? Please check on that also. Okay, so yes, so we are discussing about the challenges here, team. The first thing was infrastructure readiness, and the second thing was about your scalability, right? Scalability is nothing but, if I want to scale up my infrastructure immediately, then how much time would I require? Let's say that tomorrow is nothing but a big billion day, right? All of a sudden we are getting a huge number of requests on my application. Then I suddenly want to increase my infrastructure. Let's say that I have 10 servers in the production, but I want to increase it to 20 servers in order to hold the new load that is coming into my infrastructure. So how much time would I require to scale this infrastructure? To scale some 10 extra servers, how much time would I require? Right? This is also a big question here. It is not that not possible, but it takes a longer time to scale your infrastructure. That is the scenario here. We need it on demand nowadays. Whenever is required, we need to do it immediately, but that is not possible still with the scalability. Is still a question with your, Agile model. That is what is another thing. And another question here is about the quality of the product, right? The quality of the product means that, as I said, like we are developing your application very faster and we are trying to release this into the market faster, but are we testing this application thoroughly, right? That, okay, let's test this, okay, let's test on the top, and you might, right, the QAs might be feeling sometimes a little, right, and they start, not testing the application properly, but you still released into the market. So the quality of the product is getting compromised sometimes because of the tight schedules that we have it, right? That is what is maybe compromising. So we should not be doing that also. So how to achieve the thorough testing or a continuous testing on your application side? Ensure that your end user should not have any issues. That is what we are trying to achieve that. Okay. So now that is the thing. And finally, we have a limited release windows. Sometimes, team, where you have basically you develop your application and the feature is ready, right? But you're still not able to deliver it to the production because there is a release window or there is a maintenance window in which only you need to deploy your application. Let's say that my maintenance window is on Saturday night, but my application feature was already on Monday itself, right? Still, I need to wait for the maintenance window to deploy this application. There are limited release windows we have. Still, process need to be improvised there. Means that whenever we are developed your application, whenever the feature is ready, we are not continuously delivering into the production, right? So where we need to achieve that also, that is what we are trying to achieve. But with Agile, that is also a question. We have minimal release windows. If you slip your release window, then you have to wait for the next window again until you need to deploy the new feature into the application. So that is also a good challenge here. That is what we are trying to do it, right? So this is the process, or this is the process we want to improvisation. So how can we do this? That is, how can we ensure that the infrastructure is getting ready immediately? I can scale up my infrastructure immediately if I want it. Quality of the product should not be missed out, or should not be taken into the consideration, right? And finally, we should not be depending on the release windows or maintenance windows. We should be able to deploy your application into the production, right, to the end user as it is ready, right? That is what we need to achieve here. So that is one of the things. These are the challenges that we need to overcome with your Agile process. So it becomes, more more value to your end users. That is what we are trying to achieve at the end of the day, right? So this is what it is, a team, about your, quick challenges about your Agile. So what we need to do basically, so we need to go for a shorter deployment lifecycle or deployment cycles, which means that we need to deliver the application very frequently than we are doing right now. We are delivering frequently only, but we need to go for more frequent deployment than we are doing right now. That is what we are expecting it. Reduce deployment failures, rollbacks, and time to recover. So you need to reduce, nowadays, if you are doing faster, you might tend to do some mistakes also. You should not be doing those things. It means you should completely avoid the deployment failures. Once the application code is ready, when you are delivering into the end user or production, ensure that that is going successful always, right? In case of any issues also, what is my rollback strategy, right? If there is a issue in deployment also, how quickly I can roll back to the previous version, so that, time to recover also you need to have consideration, and then we need to do this one. So how can we achieve this one? We need these kind of deployments. At the same time, we should not be failing in the releases, maintenance windows, or deployments basically. This is what happened, and then after this one team, we need improved collaboration and communication. Why I'm saying this improved collaboration and communication team? Because nowadays, right, in every day, if I ask about a developer, what is your production environment, they usually don't know, right? I'm not saying that not everybody don't know it, but there are a lot of people, or 80% of the developers, they really don't know about their production environment. Means that they develop the application, but they really don't know how this application is used by end user, or how this application is deployed into different environments. They really don't have any idea at any point of time. Now that is what it is, right? Which means that developer never worries about your infrastructure side. Whereas the same thing from the infrastructure folks, they never worry about what is there in the application, right? They just take the code, they just deploy into a server. That's it. So there is a lack of communication between these teams, which is actually giving some sort of problem while you're ensuring that the quality of the product, or while you're maintaining your product in your production environment. So we need to have some kind of improved communication and collaboration between various teams, those who are working towards the same project or a same, delivery of same application, basically we can call it. At the end of the day, everybody is trying to ensure that your application is used by end users perfectly without any issues. Now, why can't we build a single team, or why can't we ensure that these all teams works together to ensure your application is stable in your production, or application is always used by your end users successfully? So this way, right, if you make them as a single team, or make them like a better collaboration or communication between these teams, now you would automatically see that increased efficiencies will automatically improve it, and then at the end of the day, we will have a stable application in your production. So that is what we need team. We are trying to achieve this process. How can we achieve this process is something, right? This is what it is, right? Again, so why are we saying that improved collaboration and communication is required here? Because we have a big blame game goes on. Like if you take an example team here, whenever you have a production call, right? Let's say that you have an outage call in your organization, right? So whenever join the outage calls, then usually the infrastructure folks would join first of all, right? Everybody joins from middleware teams or database administrators or network folks. Everybody would join it. Now nobody able to find out the issue. They finally call the developer, and the developer comes and says one beautiful word here, says that the application is working fine in my environment. That's your environment issue, right? It is nothing but we call it as a blame game, right? Because operation folks or infrastructure folks are blaming the developer is blaming the infrastructure folks again. Kind of a blame game is happening between your different teams. So this should be avoided to improve the the stability of your application. Rather than giving a blame game, so let's work as a single team. Then you definitely do not blame each other, and you can easily maintain your application into production. So that is what we are trying to achieve. So works fine in dev and then ops problem. We should not be saying these words anymore in nowadays. That is what is the expectation also, right? So this is where it is, team. We are talking about something called as, yes, it is all related to Agile. Okay, this is where we are talking about the next process, nothing but your DevOps, right? So I'll stop here for a minute, team. If you have any questions, you can go ahead and then put your questions. Otherwise, I'll move on. Is everybody clear about the discussion that we had it so far, or what exactly we are trying to give it here? Yes, everybody? I hope everybody is clear. So thank you so much. Okay, one question. Yes, what is the question? Is it all related to Agile? Yes, mostly the Agile process. Okay, great. So, Tosadine, let's talk about your DevOps, right? So, what is DevOps and why DevOps? That is what we can discuss about it. Okay. So, okay, before we discuss about DevOps again, it means overcome from the Agile problem. That's it. Is Agile a continuous development process? That's called, yes, Agile is called as continuous development process only. That is what we had it so far. Exactly, team. I'm looking at your questions. Just give me something if you have anything. Okay, that's correct. Okay, so how application is tested frequently if requirement changes frequently? Okay, that is what we need to achieve, right? We need to do an automation on your testing also. So the requirements is developed, then you need to have an automation ready to test your application also. The continuous testing should happen based on your requirement should is changing. Yes, that is what the continuous testing nowadays is a big word again, right? So you need to develop your testing also continuously. Automation test cases using Selenium or any other tools. You need to automate everything so that once it is deployed, then you can test your application also. Yes, Agile is continuous, but it is a continuous development process, not a continuous delivery process, we can call it. Okay. Right. So coming to the DevOps team, right? A DevOps is a process again. We are not removing the Agile process, but we are talking about this one, right? So if you talk about the questions about your DevOps process team, so there are a lot of questions comes into the picture, or a lot of definitions that are there in the market. So what exactly is the definition of your DevOps is something. Everybody may say, somebody may say that's a culture, somebody says that it's a job title, somebody says it's just a team or way of organizing the things, and a lot of things, right? There's a lot of things comes into the picture. When you talk about the DevOps, there's a lot of things comes into the picture. But what exactly is means for us, or what exactly I like it personally here. So DevOps is nothing but we call it as a reorg, not a new team to hire. A very simple thing, right? It is by a guy. So reorg, right? What I mean to say reorg is here, as I said, like earlier, we are working towards a single project or a single application delivery to the end user, but there are various teams working in your organization to achieve this process. In earlier stages, every team works in a silos, means that developer doesn't know operations or operation doesn't know the development. So we want to bring them together, right? Everybody working towards a single goal. So everybody should work together so the efficiency becomes automatically improved, right? We get more efficiency when you work together. The teamwork will give you more efficiency than single individual work always. So we have to bring all the teams together, those who work towards a single goal or towards a single application delivery always. So we have to bring them all together and see that, okay, you're all one team, think about your DevOps team now, right? And then say that you're all DevOps engineers, then you start working on ensure that we don't know what you do it, but ensure that you are application is stable in the production environment and you need to give your application enhancements or features out to the end user to very frequently, or the deployment should go in a very frequent way. That is what we expecting it with a DevOps model. Now, if you go for technical definitions team, technical definitions about your DevOps, we can call that DevOps is Agile IT operations delivery. Simply earlier Agile was a continuous development process only, but now we are calling it as, we are bringing the same Agile into the IT operations side also, where we are calling it as Agile. DevOps is nothing but Agile IT operations delivery, required to match the cadence of your Agile IT development. So that is what we are expecting it. Now, in other words also, the DevOps is a philosophy of unifying development and operations at a culture, practice and tools level to achieve the accelerated and more frequent deployment of changes to the production. So this is what we are expecting, team. So at the end of the day, we are expecting more frequent changes in your production or more frequent deployment to the production, which means that whatever the new requirement, whatever the new changes, you have to immediately send it to the production so that end user is happy or end user starts enjoying your features of your application. That is what we are trying to achieve at the end of the day. Whatever the process we followed so far, we are trying to ensure that our clients are happy, our customers are happy always. That is what we are trying to do it. Now, these are the technical definitions one more time. So DevOps is nothing but a philosophy of unifying development and operations at a culture, practice and tools level to achieve the accelerated and more frequent deployment of changes to the production. So that is what we are expecting with a DevOps process, right? How to achieve this one? There is various ways again. Various technologies, various tools comes into the picture, depends on your requirement. Okay, so that is what it is. Again, the pillars of DevOps is nothing but your tools, process, and people and culture. That's what we call it. The important thing that we are trying to achieve with the DevOps is something infrastructure automation. That's where we are trying to automate the infrastructure as a code so that your infrastructure readiness issue becomes resolved, right? We talked about the challenges, something called as infrastructure readiness is a big question. So we want to automate such a process. So infrastructure can be written as a code and you get your infrastructure ready in a matter of minutes. I know everybody thinks about your cloud, so that is what it is. Nowadays we are trying to move to the cloud where you can get infrastructure as a code also. That is fine. So that is why we are doing. That is, first of all, we need to bring up our infrastructure, then you can deploy your application, right? Now, how do you deploy the application again? We have to deploy this continuously, right? That's what we are expecting again, continuous delivery. So far, we are doing the continuous integration with, Agile process or Agile IT or Agile, process in the development phase. We have to bring the Agile into the operation side also, so we can achieve the continuous delivery part also. So that is what we are expecting, team. That is what is the expectation of DevOps always: infrastructure automation and the continuous delivery and reliability in engineering. So that we are engineering so much process here, so that to achieve the goals of your DevOps. Now the engineering should be reliable always. We can call it reliability engineering also, one of the pillar of your DevOps. That is what we talk about DevOps team. Okay. Now DevOps consists of various tool sets here. This is a very simple thing. We talked about it, of course. Now I hope you guys are clear about the DevOps, right? What is DevOps and then why we are trying to move towards the DevOps. Does anybody have any question before I move on to the next thing? Yes, anybody? Is this only configuration part or a process? It's a process completely, guessed. So, okay, good. So I hope I'm going slower only, team. So if you have any questions so far, I hope you understood now from where we are trying to achieve or from where we are trying to move to the DevOps model, right? At the end of the day, the goal is to deliver your application to the end user. That is what we are all trying to do it. Everybody clear so far, or any doubts? Thank you. Good. So now that we understood what is DevOps, right? Let's talk a little bit about the DevOps operation side, right? Let me go back to this slide. And then we are changing the application architecture also to microservices nowadays, right? I hope everybody is hearing about the microservices. Microservices are nothing but, we are further, dividing or making the application into bits and pieces, which means that earlier we used to deploy all our application code as a single executable file or a single process, we can call it, right? At the end of the day, you get a var file, right? Or, kind of when you write the code, the application is converted as a, executable format, just like your .exe files. in Linux, in a Java application, we have something called as var file or er file. All your application features are bundled in a single executable file when you go for the previous stage, right? But when it comes to the microservice architecture, rather than creating every feature of your application as a single executable file, we divide them, right? Let's say that login module is a separate function, separate executable itself, separate process itself, right? Let's say that once after you log in, let's say banking application here, the credit card section is a separate piece and the debit card section is a separate piece. Your account is a separate piece. Now in the front end, you might be seeing as a single application, but in the back end, where we deploy this process as a different processes, right? Not a single process, but they are all different process internally communicating with each other and providing the services to you in the front end. That is nothing but we call it as microservice architecture. Make sense, everybody? The microservice architecture, we are further dividing our application features into sub-components and deploying them as a separate pieces, separate individual pieces. So that, if there is an issue with only the login module, or let's say the credit card section, I can take down only the credit card section, right? And then I can redeploy the credit card, fixing the code and redeploy. During the rest of the time, the rest of the application is functional, and then you can see that end user can see that the application is not going down completely, right? This way you can actually maintain 24/7 applications also without them. And we can even do the rolling updates, which means that without a maintenance window or without a downtime also, you can easily deploy your application into the production. With microservice architecture, it is easy to implement the continuous delivery process also. That is why we are towards, or everybody is towards converting your applications towards the microservices concept, right? Microservices brings more advantages in maintaining the application 24/7, as well as rolling updates, no downtime applications, we can call it. Scalability also becomes very easy with your microservice architecture. So that is why everybody is trying to implement microservices for their projects or applications. That is what it is. Now finally, we are talking about the containers, right? On the infrastructure side, we are not replacing the virtual machine with the containers. Don't think about that. Earlier team, we deploy this application, right? The single executable file as a single server process. That is what it is. In order to deploy this one, we used to have a server, right? Means that there is a server that where, we just take the var file or er file and then we just deploy that into the server. That is what we use it basically, right? Now with containers, what exactly we are saying is, rather than deploying only your application code, and containers is a big topic theme. It takes at least 1 hour to explain the containers. But in a simple format, what I can say is the containers is nothing but, it's not only the application code that you want to deploy into your server, but rather than that one where we are facing a lot of issues, dependency issues like application dependencies, version mismatch issues. There is a lot of issues that we will face usually when you deploy only the application code into different servers in a different environments. So rather than doing that one, right? Let's package or let's bundle a software package which has everything to run your application. Means that if my application code requires to, in order to run my application code, if I require Java 1.8 and let's say that Tomcat server, let's say that there are OS dependencies, along with that your application dependencies. Means this is whole together to run your application, right? Application runtime environment, we call it. In order to run your application, there is a lot of dependencies that are underlying from your operating system to the Java to the Tomcat web server that you hosted. Finally, your application code and then your application code dependencies. All these things need to be packaged in a single package. That is nothing but we call it as an image file basically. That you bundle this package and keep it ready, then you run it the image instead of running your application. So this becomes your container. The container is nothing but a software package team which has everything to run your application. In simple words, a package or a software package that has everything to run, everything dependencies, all the dependencies to run your application together. That is what we are trying to do it. So in the infrastructure side, we are trying to deploy it as a containers. And this containerization brings a lot of features, again, a lot of advantages. Scalability becomes easier and deployment becomes easier, right? And then auto scaling feature comes into the picture, and then auto healing features also comes into the picture, right? Now, if you want to deploy this one, whether you want to go for a cloud, yes, we can go for a cloud also. Cloud is nothing but nowadays, right? The infrastructure readiness is an issue, but if you go to the cloud, infrastructure readiness issue becomes easy for you. the efficiency becomes more faster for your application deployments. That is what it is. Now the cloud is nothing but it's a pay-as-you-go service, or it's kind of a service that is in your fingertips. You can go there and you can click a single click and you get whatever you wanted, and you can pay as you go. Whatever you use it, you pay for it. That's how the life has become so easy for us. And then we started using the cloud services also, which makes our life easier, right? So this is about the infrastructure that we are trying to create with the DevOps model team. In DevOps model, our goal is to build a continuous delivery process, right? Continuous delivery process, ensuring that your infrastructure is ready, and then ensure that your deployment doesn't fail, and you need to do a more frequent deployments into the production. That is what is the expectation with your DevOps model, right? So hope that is clear for everybody now. What is DevOps, right? That's what it is about, team. And then this is what we discussed about so far, whatever it is, the blame game and everything. So if you have a clear with this one, then we can just quickly jump onto the tools, various tools that can be used by your, to implement this process. That is what we can talk about it a little bit while, and then we can just jump onto a demo afterwards. Okay. Is it clear, everybody? Is container part of virtual server? It can be deployed in a virtual server also. Yes. So container is not part of the virtual server. The containers can be deployed on a virtual server also. It's like cluster model. Yes, kind of a cluster model. Okay, I'm looking at this. So this case with microservices, it would be very difficult to manage a big application. Is it? Not really, I can call it. When you have proper orchestration deployment tools, if you use the tools properly, that becomes very easy also. It's not, if it is a big application, not really. No, you need to have, we have such tools which will help you, maintain these applications very well, such as container orchestration tools also there. They will help you maintain this application very well. Though you split a big application into simple microservices, we can still maintain them very easily. That becomes a life, right? Okay, so is that same Azure and DevOps? See, so DevOps is DevOps everywhere, right? Whether you implement it on a cloud or on-premise, the DevOps model is same thing. Okay, that is the only thing. So to overcome the challenges of Agile, DevOps is introduced, right? DevOps is a process. That's absolutely correct. Any example? I'm just looking at team. Is container contains OS in image? Yes, absolutely. It contains an OS also in the image. When we go for the course, full course one, we can discuss more about the containers. Yes, but for now, yes, the container also has its own operating system in it. Okay. Okay, so just give me a second here. Let me look at your questions meanwhile. So there are a few questions, I see it. What is the difference between Agile and DevOps? The Agile is a continuous integration process or continuous development process only, whereas DevOps is the continuous development plus continuous delivery, right? That is what it is expected. Is there a scope of telecom? It's everywhere, basically. DevOps scope in telecom, right? So everywhere is a software, so yes, the scope is in telecom also. You can think about your project based on that one. You can discuss. Okay. So what is the role of a Kubernetes here? Kubernetes is nothing but your container deployment tool. So in order to maintain these containers, we use Kubernetes. Okay. So means we need to configure those tools. Yes, we need to configure the tools team. That is a simple expectation. Is container okay? Okay. Good. So I hope I answered all of your questions also. Right. Now let's jump on to this quickly. There are various tools, means that as DevOps says that, now you need to have an idea about, or a DevOps engineer need to have an idea about your development. Have an idea only, we are not asking you to implement it, but have an idea about it, as well as your code area, and then, how your application is maintained throughout the life cycle. Means as part of this life cycle, right, from the planning to the, delivering of your application to the end user, you need to have an idea how this is working whole life cycle. So that's the role of your DevOps engineer. Right? DevOps engineer should have an idea. That's it. So in order to implement this continuous process team, we make use of various tools, such as continuous integration tool, where we can discuss about continuous integration is nothing but a software development practice in which you build the test software every time a developer pushes the code to the application, right? The repository basically. So that's what it is. We need to continuously build and test the application so that you ensure that your application is stable, will be stable in your production, right? There are various tools for continuous integration process. One of the popular tool is nothing but your Jenkins, right? These are various tools that you can see it on my screen. Foreship, Bamboo, Travis CI. Everything has its own importance, but Jenkins is widely used because it's open source, right? If you go for it, what is the comparison between these things? Open source, and you have multiple plugin support, community support. You have it, supports all repositories. Like Jenkins is a continuous integration tool, so which can talk to a GitHub or SVN or whatever the source code management tools you have it can talk to it. Then Bamboo, not an open source basically, and then Travis CI also an open source, but a very few plugin support, not widely used, so you don't get a support so easily. There's a lot of things comes into the picture. Okay, so continuous deployment tools, like we talked about continuous integration, where you continuously integrate the code and then you produce your WAR file, or kind of an executable file that can be deployed onto a server. That is what we actually do, right? That is nothing what we try to achieve. Now, how can we deploy this WAR file or an executable file into a server? So we need to build a process in such a way it can be deployed continuously also into your different environments, right? So that is where we come into the tools of continuous delivery or continuous deployment, right? So this is something that, continuous integration, again, we talked about it already. So with the CI server or continuous integration server, we build our artifact, which is nothing but your WAR file, right? Once after you build this one, we actually go into or deploy into a different environments in your organization. We don't directly deploy into a production environment. We have various environments such as development environment, QA environment, then pre-production, and then production, right? These are the various environments that you usually have it in any organization. You have to, deploy your application into the different environments, ensure that it is working fine. Then finally, you deploy into the production. That is what we actually do it, right? So finally, our goal is to deliver into the production. This should be automatic also nowadays. Now, team, so far 1, 2, 3 are automatic. That is what we did it. Now, with your DevOps model, we are trying to implement something called as automatic deployment also, which is called as continuous delivery of the production. That is what it is, right? Now, how can we implement this? There are various tools which will help you, build this complete pipeline. We call it as complete CI/CD pipeline, right? Continuous integration and continuous delivery pipeline, where we can achieve this thing using various things, various tools. We can do this one. Puppet, Docker, Ansible, Salt Slack, Chef. These are all various configuration management tools plus containerization tools nowadays helping to achieve your continuous delivery process in a simple way. Okay, that is what it is. And CI/CD pipeline example. So team, here we will just jump onto the example. I'll show you a quick thing, right? I'll show you a quick example of CI/CD demo now, how to implement this complete CI/CD. Right, so let me draw this a simple way, right? So everybody is able to see my screen now, main screen, I believe. So let me give you things what we are trying to achieve with the demo. Then I'll quickly execute the demo also, and then you will see that what exactly going to happen. Okay. So team, here basically we have our source code usually in a source code management tool. Let's say that this is our SCM, which can be nothing but your GitHub, right? In a public way, because we are implementing a general scenario here. Now we're going to use a public repository, which is going to be GitHub, which means that my source code is available here completely. Whatever the application code you have a source code available here in a simple way. Now the developers keep on pushing the changes into this repository. Yes, they keep on pushing the changes into this particular repository. They commit the changes, they save the code there every time, right? Now this is what they do it. Now after this one, team, we're going to have a process or a server, basically we call it, which is nothing but your CI/CD server, I call it. Okay, CI/CD server. Basically, and this is nothing but our Jenkins, right? Jenkins, basically you have it here, which is going to monitor your repository completely, right? This is going to monitor this repository. Now this is where we need to define our various steps, right? What exactly you're trying to do it. Let's say that the various steps are nothing but, team, we are using continuous integration to produce a WAR file. That means that you take the source code and then you build the code, right? Build is a process basically where you produce an artifact or a deployable artifact into a server. That is what it is. So here, team, the Jenkins server, first thing it is going to do is get code from SCM. That is what it has to do it. Second thing is it is going to build the code, which is nothing but build code, which is nothing but we call it as package, right? Package nothing but which is going to generate a WAR file. Just assume that it is going to generate a WAR file first. This is what it is going to do it. Once finally we're done with this, right? Since we are making use of containerization here to deploy your application, as I said, like instead of deploying the simple var file, we're going to containerize, right? We're going to keep this var file and all of its dependencies in a software package called as a container or a Docker image, we can call it. Here we're going to use a process called as building the Docker image or a Docker process, right? So once this var file is got in, we're going to build a image called as Docker image. Okay, this Docker image will usually have your var file, right? This Docker image, we're going to have it, build a Docker image which will have the var file plus all the dependencies that are required to run your application. When I say all the dependencies team, the image would consist of a lot of things. I'll just tell you. Okay, once this is done, since this is happening on a Jenkins server here, right? Our production environment or different environments are hosted differently, means different servers basically. So your Jenkins server should talk to your end, production servers and deploy the application there, which means that the image built here will be available only on the local system. So we have to push or publish this into a central repository. Push image into Docker Hub here. We call it as Docker Hub, right? This is what we are trying to do. Docker Hub is a place team where we host or where we publish our images, just like you use an Artifactory to store your WAR files. Docker Hub is a place where we publish our Docker images. That's it. Now once you publish this there, right? After this one, deploy application, right? Deploy the containers into prod, right? Into let's say that production environment going to deploy. This is what we are trying to achieve with this process. Means that your Jenkins is going to do all these steps team. That is what we try to achieve here. Means that whenever there is somebody checks in, that is what has to be happen. Now as I said, like, right? So whenever you build a Docker image, the Docker image will be pushed into a repository called as Docker Hub, right? The Docker Hub, this is where we are trying to push it. Docker Hub will hold your Docker image. That is what we're going to do it. So, okay, so Docker image will be pushed into a Docker Hub. Now finally the Jenkins is going to publish there, but along with that, Jenkins is the one which is going to deploy your application into a environment called as production, right? Let's say that this is production environment, I have it, right? The production environment is nothing but, let's assume that we are going to deploy the containers. So in order to deploy the containers, or a container orchestration tool is required. The container orchestration tool here, nothing but we're going to use something called as Kubernetes, right? Let's say that I have in production, I have a Kubernetes cluster, right? This is what I'm doing it, right? And whatever the Kubernetes cluster team, a cluster means that a group of machines basically, right? You have multiple machines in your production environment. Let's say that this is what it is. You're gonna have it, right? In a standard way, just try to understand. In a Kubernetes cluster, there will be a master node, right? This can be called as your master, a simple way, and these are worker nodes. Okay, means that I'll tell you why we are doing this. Okay, now here, right? Whenever we want to deploy our application through the Jenkins into a cluster in production, Jenkins can talk to this master, right? And then master will start scheduling the containers into this different process, right? This is what it is going to do it. So this is how it is going to deploy, right? This way you can achieve your continuous integration and continuous delivery till the production. Whenever there is a commit happens in your GitHub or a centralized source code management tool, now this is what we are trying to build it, right? So here the CI/CD server Jenkins going to get the code, build the var file, and then it is going to build the Docker image also. Once it is built, it is going to publish the Docker image here, and this will trigger a deployment here. Whenever it triggers a deployment, the Docker image will be pulled from the Docker Hub into this nodes, and it will start creating the containers in the environment, right? This is what we're gonna get it done. Okay, this is what it is like. Pull Docker image into my environment. That is what you're doing. Okay, this is what we are trying to achieve. Okay, so this is the demo team which I'm going to show you right now. It will be quick only, so I'm not going to create whole process because I have already created this master in this cluster already, and the Jenkins server is ready for us. And then we do have our repository ready, right? This is going to be our repository team where I have some source code and everything. Okay, and this is what it is. This is a hub where we're going to push the image, Docker image, right? And this is our continuous integration server or CI/CD server, through which we're going to achieve this task completely. Okay, so in order to implement this pipeline team, let's create the things here. Okay, before that, let me show you my cluster also where I have my Kubernetes installed. Okay, Let me talk to this one. Okay, this is my Kubernetes master team. I hope I have. Okay. Okay. Let me take this, restart the session. I'm just logging into my Kubernetes master, which is a production server. You can think about it. Okay. So here it is. Right now, if I say your get pods, a pod is nothing but a container in your cluster team. Basically, don't think about pod is something. It's a Kubernetes concept. So a pod is nothing but a container or your application container deployed. Right now, you can see that there is no containers deployed. It says that no resources found, which means that there is no containers running in my environment, right? Now, once after we're going to run the things here, once after we're going to implement the CI/CD pipeline completely, then we can see that the containers deployed into our environment successfully, right? Let's create it here. Let's create a pipeline script or a complete pipeline, right? Here you go. Let's say that CI/CD. Right, so let's say that CI/CD pipeline, I'm going to name it. Now we're going to creating a pipeline, so let's go for the pipeline here. Now where exactly I have defined this pipeline team? Basically, you have some scripts available in your repository here. So this is something called as a pipeline script, we call it. So where I have defined what are the different stages, right? Whatever I mentioned in my present here, these 5 steps are mentioned in this particular script. This is nothing but automation, right? Complete automation. The first step is nothing but your, check out the repo, which is nothing but is going to get the repository. Then after that, it is going to build an artifact, which means that it is going to produce a WAR file. After that, it is going to build a Docker image. And after that, it is going to push the Docker image. Now, finally, it is going to deploy the containers into your Kubernetes. That is what we're going to do it. Okay. Let's look at this now. I'll just create a pipeline here. You can put that script directly, or you can get it from a source code management tool also. Let's say this, right? And then finally, Git is my source code management tool here. So I can just give this repository URL. Okay, let me click on this. So this is my repository, right? From which I have the source code and everything is available here. I'll just gonna give the repository URL here, and the name of your script here it is, right? The script path. So my script name is something team here, which is Jenkins file K8s, so I'm going to give this name here. Okay, Jenkins file K8s. This is what is a very simple thing. Now save it, right? So once you save it, in order to run this one, you can just run this. Before I run this team, I just showed you like there is nothing running here, and along with that, I can show you Docker Hub also. The image is not available here. This is my repository in my Docker Hub where I'm just trying to get it. So here you see that there is no images available also. So let's look at this. Build now, right? I'm just running this job and we'll see what happens. So here you can see the pipeline running team. It is nothing but it's just created. It check out the repo, which means that it is got the source code for you. Now it is actually building the artifact, which means that it is actually creating your WAR file. That is what it is trying to do it. First stage is done, second stage is done. And the third stage is nothing but your build a Docker image. That is also done. Push to Docker image. This is also done, right? Now finally it is deploying in your cluster. This is what it is doing it. Various stages. This is nothing but your complete pipeline, right? That is what it is. Okay, now it is deployed also team successfully. It is very simple. Now let's get back to the Docker Hub first of all and check whether the image is available. Okay, now you can see that there is a latest image got pushed here a few seconds ago. That is what is a very simple example. It pushed successfully. Now this is what happened. Our pipeline is successful. Now let's get back to our Kubernetes cluster, right? Now let me say that get pods, right? You see that there are 2 containers running here successfully, right? This is how you can achieve your complete CI/CD pipeline, right? There is something happens again in your repository, then it can trigger automatically, then it can build whole this process. It keeps on creating. It keeps on creating your artifacts, create a Docker image, and then finally deliver into production. So it is a very simple demo team, but in a real-time scenario, you need to think about a lot of process in your type of application based on your application types. You can always go for it. Okay. Okay, what is the difference between Jenkins and Docker tools? Jenkins is a build automation tool, and whereas Docker is a containerization tool, which means that Docker is the one which is running your containers. Okay. We need a physical server for CI/CD server. Any server is a good guest, so it is not that you require only physical server. You can run on virtual server also, that is good. A server with some operating system with Jenkins installed, that is good enough. Not able to see Kubernetes cluster. We can't see your screen. Tim, are you having any issues in my screen? I think so. Can you please share the pipeline script? Yes, I can share it, no issues. Okay, so this is what it is, a very simple example, right? I hope you are able to see my screen now. Somebody who reported not able to see my screen. This is my application running it. Now if I want to access this application team, I can access also. Let me kubectl get service. Basically I expose the service also. So my service is nothing but this one. It is running on a port number called as 3002. So let me access this one. Let me take an IP address of your machine where it is deployed, right? This is where it is deployed. Now if I go back here, right, let me access this one. Okay, the port number is 3002. So, okay, right, this is what it is, and your application URL is something called as address booking. Okay, so this is what it is. So your application is deployed successfully, and then you're able to access your application successfully. Okay, this is what it is, team. I hope you're all able to see this. Application is launched successfully. I think there is something it is giving. Okay, this is what it is, right? Your application is deployed successfully, and then I'm able to access your application. Okay. Okay, so this is about the team. About the demo and then what we are trying to achieve with your DevOps and all. I hope you're all clear with this concept here, which is we tried just implemented also. Okay, so this is what it is, CI/CD pipeline and Docker Hub. This is a public repository. If you guys would like to use it. There is no question about it. Okay. Before I move on, team, we are just done almost, so just a few more minutes. That's it. Can we yarn instead of Kubernetes cluster deploy the code? See, it's the end of the day your requirement, right? You can deploy it's a Kubernetes cluster or a Docker Swarm or wherever you want to do it, you can do that. Okay, but you have to implement the process below. Scripts are inbuilt. Those scripts are available with your repository. So I kept it ready for us because we can't implement everything here. I just kept it ready. So everything is available in the repository here. When you said nodes, host and Kubernetes that time, I couldn't see the screen. Okay. Are you able to see the screen now? This is what it is, right? Kubernetes cluster. This is where I'm just deployed the application. This is my Kubernetes node also. This is where the container got deployed. These two are the machines, which I have it, a master and the node basically. Okay. Okay. So team, I hope you're all clear with the demo. If you still have a question, right, we can discuss more on it, but this is what it is. But let's continue if you don't have any questions also. Correct? Still not able to. So you might want to relog in, guest. Maybe everybody else is good, I believe, but you have the issues. That is the only thing. Okay, so that's about it, team. And the CI/CD pipeline example, we just saw it successfully, right? And then that is what it is. Sorry, this is what it is. Now this is what we did it basically. If you try to understand, we have version control in which we have the source code along with all the deployment scripts. We have built the code. Internally did the unit testing or something, everything is done. Then we deployed the code. Auto testing is not completed here. We did not test anything. We just deployed the application. Testing comes after your, let's say that your application is deployed into a QA environment. Then you can implement the test. Here we deployed only into a single environment team. Usually CD involves multiple environments. First it goes to the QA, then deploy the application QA, right? And then you test the application, that is the test environment here. Then after that one, if it is testing is good, all the certified application, then we deploy into the next environment, which can be your production. Okay. Here we just directly deployed into only single environment. That is what we just showed you, but this is how it looks like. Okay. Deploy and then measure and validate. This is what we can deploy. Okay. So this is a continuous process. Code commit, whenever there is a commit happen, the build happens, unit test, integration, everything will happen in the CI pipeline, and the CD pipeline will continue to a stage and production where you deploy your application and ensure that it is available for the end user automatically. That is what we are trying to do. Okay, deploying this, this is about the containerization again, right? This is about it. how we deployed our application. Docker file. I mean, in order to build our Docker image team, we used a Docker file. Docker image would consist of this one. As I said, like, right, when I say Docker image is built, this Docker image has actually this content. Okay. Docker image here has something called as operating system, right, and Java, and you have your Tomcat server because I deployed my application in Tomcat. Finally, you have your WAV file copy. This whole application bundle, right, this is called as a Docker image here, which we create, right, the fourth step here, Docker image. And we run this image in the production, that becomes your container. That is what it is basically. Okay, here you are running two different containers of your same image in our production. Okay, so this is what it is. Now that is the Docker image. What exactly we have built the Docker image. Now with that, so DevOps and its applications, I hope here I'll pause for a minute, team, if you have anything again. So requirement, I think it's came to the first again, so let me do this again one more time. Okay, so this is what it is, Docker, and then we pushed the Docker hub, and then we finally deployed into a production server. That is what we actually did, right? This is what we actually did. All of the dependencies like Docker CLI, Node, Git, etc. need to be installed in CI/CD server. Absolutely correct, best. So you have to install, because you're doing the Docker images, so you have to have a Docker client and everything. You have the Git and then build server, and everything will be there on your Jenkins server itself. Okay. Please share the PPT. I think you can get in touch with Mac now, so they will share it with you. Okay. So finally, there are various ways to monitor your application. Once we deployed our application in the production team, we start maintaining the application, which means that whenever there is an issue with your infrastructure, you should come to know. That's where the maintenance comes into the picture. As per the software engineering definition, if you think about it, we're done with the development, we're done with the operation, which is nothing but the deployment to the production done. Once after that one, we are talking about the maintenance phase, right? The maintenance phase where we include a lot of monitoring tools or log tools, whatever it is. So whenever there is an issue in the infrastructure, if it is faced by your end user or whatever may be, these tools will help you identify the issues in your infrastructure, and then you can immediately react on them and you can try to fix the issues accordingly. So the monitoring tools, that is what is the importance here. Zabbix, Nagios, Groundwork. There are various tools in the market. Nagios is one of the better tools nowadays. We have it. There are other tools also, but yes, there are various tools that you have it for monitoring. Okay, so this is about it. Finally, scenario, if you would like to take it. I mean, this is all about, we already discussed these things. What is LS here? The simple hotel management application provides software as a service, right? Whether through the mobile app or website, in person, or this one, right? Now this is what it is. Problems, you might have it, various problems with this single application, right? Problem solution is something you need to implement DevOps in order to achieve your goals, ensure that you maintain and you ensure that you want to release latest features into your application. It is that DevOps process will help you achieve the process accordingly, right? So this is what it is. They needed a DevOps engineer. Again, whatever things we discussed so far, the same thing here. Someone with experience with the DevOps tools, you need it. Implement automated deployment and scripted configuration. That's what we just saw it. We implemented something called a scripted automation or configuration, so that we were able to deploy our application into the production, right? Implement DevOps solution for team collaboration. DevOps process, again, which will help you, bring a collaboration between various teams, which is required process. Achieve the continuous integration and continuous delivery. I think we just achieved that one using our continuous process, right? Demands of a DevOps engineer. Now I hope I might have interested who should take the DevOps engineer or DevOps courses or something. So DevOps getting more exciting in year 2019, and it is very in the market now. It is like a buzzword theme for DevOps. It is very popular now, so you need to think about everything is growing, right? With DevOps, this is Google Trends. We have it. It is growing day by day, right? That is what we are trying. And demands of your DevOps engineer, again, every organization, every big organization trying to implement this DevOps only completely. So advanced system engineering, so build a DevOps solution using relevant tools. There are various tools, team. Every organization may have different tools. DevOps comprises of latest technologies and latest tools. Depends on the organization, the tools may vary a little, but the process remains the same. Okay, that is what we are trying to tell you. The process remains same everywhere, but the tool set may be a little bit different. Depends on the organization sometimes. Okay, that is what it is. And who should learn the DevOps again? Right, this is about it. Software developers, if you are coding, yes, you can go for it. So organization nowadays prefer a developer who not only can write the code, but also knows about the infrastructure. That is what I said, right? So it is that you need to know your infrastructure also if you are a developer. Just the requirement to know it, not to implement anything, but just you need to have an idea. That's it. Okay. If you are a QA also, yes, you can still go for this. Continuous testing can be implemented using the DevOps technologies again. So if you are a QA for continuous testing area, you fit for it. So you can achieve the continuous testing process through this one. That is one of the important things for your, a quality analyst. You can go for DevOps again to learn how to use continuous testing and all. So sysadmin, of course, he is the one who is doing the complete operation, maintaining the infrastructure or creating the infrastructure. So he needs a better here, good scripting and computer system knowledge on Linux, installing, supporting, and maintaining servers. So nowadays, the dev teams are agile and then wants to small but frequent releases. So to stay ahead of the competitors and to cope up with the pace of development, sysadmins are required to automate repetitive tasks like installing servers, configuring those servers, etc., and know how configuration management tools like Puppet, Chef, Ansible automate infrastructure provisioning, right? As like infrastructure readiness is a big question. So in order to automate that one, we need to implement DevOps again. That is where it comes to the picture. Okay. So as a sysadmin, yes, you are best suitable for your DevOps engineer roles. You need to automate all the process which you are doing manually earlier. That is where we talk about it. Okay. So about that one and the storage, and then if you think about other areas of your things, the storage admins, SAN admins, these are various roles in an organization team. Not only your developers and then operation folks and maintenance folks. There are like networking teams, storage admins, VMware administrators. There are various teams, security teams, these teams who should take this. That is what is the question here. So if you are a storage admin, still you can go for it. In your area also there is a scope of automating the things to provision the storage automatically and all that stuff. So those areas also can be implemented using your DevOps again, right? So that is what it is. Who should go for the scopes again? Finally, we have database administrators also. Since the database administrators also write a lot of coding in order to deploy the database scripts and everything, so they can also implement automation in such a way that they can continuously deliver the database requirements into that one. So you can automate the process using this. So that is one of the things here. Finally, your learning path to become a DevOps engineer. These are the tool sets that we talked about it, a course curriculum that I think Magna is offering. So these are the ones which will be part of your course curriculum. That is what we're going to do it. Overview of DevOps, which we judged just now. Version control system with Git. Jenkins, Maven integration for building. Continuous integration using Jenkins. And then continuous testing with Selenium. Continuous deployment using containerization and Docker. Right? And containerization ecosystem, how it works, how to deploy the containers and everything. Configuration management, continuous deployment using a Puppet or Ansible. Both are same. Right, and then containerization, orchestration, container orchestration using Kubernetes mostly, and finally we do continuous monitoring with Nagios. That is what is a course curriculum, and we just give a quick introduction to your DevOps on cloud also. That is what it is. Okay. So finally, this is a DevOps engineer career path from programming DevOps engineer. So you can start programming, scripting something, scripting only, not programming. We can call it. He starts using various tools as part of the path where he can reach to the cloud at the end. So this is the flow team that you can think about it, starting from the version control system, right? Then you need to build automation tool, nothing but Jenkins, continuous configuration management tools such as Puppet, how to configure the servers in your production, automatically everything. You can automate using configuration management tools, CI/CD tool to help deploy your application, test automation tool to automate your test cases, logging and monitoring tool which will identify the issues in your infrastructure, right? And in order to analyze the logs quickly, then you can go for logging tools. Finally, database management will be maintained by database administrators again. Containerization tools such as Docker or Kubernetes. Docker is a containerization tool, and then container orchestration comes into the picture where Kubernetes and Docker Swarm comes into the picture. Finally, you can deploy on a cloud or on a premise. That's up to you. So that's where the ends, right? This is the whole picture that you need to come to it, right? The benefits here, which we're talking about it. So if you go with Magna, you will get a lifetime access, and then classroom recordings, multi-projects you will get it, and then 24/7 support also. That is what it is. Okay. And finally, That's about it, team. Thank you so much for listening to me. Hope you have an idea about DevOps now. What is DevOps and why DevOps? That's about it, guys. I think I can over to Aishwarya, if you would like to take over. If you have any questions.
Thank you, Naresh, and all our participants.
Thank you. Yeah, please go ahead, Aishwarya.
Thank you, Naresh. Yeah, you will receive a survey asking for feedback on this event. Your insights will shape you. We will send you a link to the recording of this event so that you can share it within your social networks. On behalf of Magna Infotech ES Services, thank you for joining us today. We hope you find this information and dialogue valuable in enhancing the Infotech ES Services. Signing off and wishing you all a wonderful day ahead. Thank you so much.
Thank you so much, everybody. Have a good day. Thank you, Krishna, and I'll see you.